make sure recorded. And I'm going to share the screen. So today we will start with a new topic about Q. So a new data structure, Q. Okay, so here. So I finally figured out the annotation, so Q. And last week, yeah, we learned another new kind of data structure, stack. And looks like you all get the idea of stack. It's last in, first out, because the forum discussion, that's very interesting. A lot of the application that you guys propose are very nice. And today we will learn another new data structure. It's called Q. And basically in the real life, we are quite familiar with the concept of Q. Like over here it says it's like a grocery store checkout line, okay? And even though we don't go to grocery store very often now, okay, but in the regular time, the grocery store checkout line, that's explained the queue. So from the grocery store experience, then you know that whoever on the front line is also arriving at that grocery store checkout line ahead of the person that stand behind, is it? So the queue, the definition is it's also an ordered collection of data items. So this is similar as a stack, an ordered collection of data items, okay? But this time for queue, you can add at both ends. Okay, so you can add at one end, and normally we call it the back, and you can remove it from the other end. So the other end, we call it front. So if I draw it, it's kind of like this, is it? So here is the back, and here is the front. So we have front here, and we have back here, is it? And so the first person going to be at the front, and then you come next, is it? And then come next, is it? And of course, checkout going to be from front, and you go into the line, it's going to be the back. You always enter at the back, is it? So it's both ends in this case. Not like versus stack, you can only add at the top. Is it? So that's one of the major difference, okay? And the other feature, if we compare with the stack, is for checkout line, is whoever, so in my drawing here, so this person is the first coming to the line, is it? So this person is also going to be the first one to be checked out, is it? So the feature for this is, we call it first in, first out. So that's its major, we call it main manner for Q. So it's first in, first out. And if we write abbreviation for this, it's FIFO versus LIFO. Okay, so this for Q is FIFO. So it's first in, first out. So that's general concept about Q. Annotation, I need to clear this of this and stop annotation, okay. And then next, let's see, I cannot, okay, so let's see some more examples about Q. So here it discusses one of the application like in computer is like you read a file, is it? And then you do some processing with the file in computer. So what it happens, your file generally speaking, it's stored in some physical disk, is it? No matter it's USB or your hard drive, or, okay, or even from the internet, is it? So it's anywhere, some the disk, is it? So the file, when your program process a file, it need first to read the file to the memory, is it? To the memory, and then you're going to process the file. So when we deal with file, it's always whatever first in, then you're going to read it and you're going to process it. So it's also following the first in, first out, is it? So it's not just this case, it's even like for the standard input, it's also like first in, first out. So that's one of the example. And the other example, like a printer job, like in our lab, is it? So a number of you send your printing job to the printer, is it? So the printer, how can the printer know like whose file is going to print first, is it? So that's also based on the concept of queue. We call it a printer queue, is it? So that's another example. And later on, we are going to come back more discussion. And today, the major focus is to discuss the major operation about a queue and how do we do the customized designed queue data structure like the stack. And we already know the concept of a queue, is it? So it's an order collection of items, is it? So it also deals with the store of the collection of items, so data. That's one of the major things. And when we write the queue data structure, so that's considered its data part. And the major operation then for queue, the major operation, just like a step, of course, you need a constructor, is it? So that's for sure. Constructor. And generally speaking, constructor, a lot of time you build an empty queue. So that's a default one, okay? So empty queue. Empty queue. And some other major operation normally is you want to check if the queue is empty, is it? And some major operation like over here, I just draw, is it? You add the item at the back, is it? So this kind of operation, so add new item, but it's at the back. At the back, is it? This operation, we call it in queue. Okay, in queue. Like in stack, we add a new item at top, we call it a push. Okay, generally speaking, for queue, we call it in queue, okay? And if you want to remove some item, is it? So you remove at the front. Remove from, and that operation we call it DQ. Okay, so it has DE and the Q. And so this is a verb because later on we are going to see another word as DEQUE. And that is a noun and it's called DAC. That's a different data structure, okay? So anyway, here, the two major operation, you add a new item at the back, it's called in-queue. And you remove the item from the queue, it's called DQ. And you also wanted to know what the front item is it? Because you always get to the front item. So that operation, we call it front. And some other operation we can also add on, like in our discussion, we will have like a toString or maybe clone, just like whatever, what we already discussed in stack. So This is a general discussion about queue data structure, the major operations. And next, what most important concept to discuss is the implementation of the queue. Okay, so how do we, just like the stack class, is it? And for stack, we implement, so our own version, the customized designed stack that we designed is we implement use array, is it? And then later on we discuss the stack class from Java collection library. And today, so same thing, we will start with our own version of the implementation of queue abstract data type. And similar, we will start also with the implementation using array, okay, using array. But here, so today there is another new concept and quite useful concept in computer science, is called a circular array. So we are going to implement with a concept, it's called a circular array. So what is this, okay? And let's see, I need to clear it, and then let's move on to the next slides. Okay, the circular array, let me see if we have the, we don't have the drawing part, so I'm going to use a whiteboard. Okay, so what's the concept of circular array? So circular array, you view it like this. So I'm going to draw. So suppose I'm going to have 6 items in this array, okay? So this array, I draw it like this. So this is start at sub 0, then sub 1, sub 2, sub 3, sub 4, and sub 5, okay? So this array, suppose we call it M array. And its size is 6 items, is it? So when we implement our queue, we need to know where the front item is. So if we view it linearly with the array, because array you cannot, the concept here is circular array, okay? So in this case, this is going to be sub 0, sub 1, and all the way to sub 5, is it? And in the queue concept, we need a front. So the front. And we also want to know where the back is. So this is the person here. The person here is it? So the front person index is 0, is it? And the back index, so we also need to keep a track of where the back item is. And when we implement queue using array, we let the back index. So here is back. Here is back. But the back index, so the back item is at sub 4. By the back index, we let it point to the 1 after it, so the empty 1, okay? So based on this discussion, we know we needed to use an array to keep track of it, is it? But at the same time, we also need the index to remember where the front item is, where the back item is it? So we need a M front to keep track of where the front item is, and the other index called M back to keep track of where the back item is. But the back, just remember, okay, and later on I will explain why we don't use back directly point where the last item is. We instead let it point to the empty slot that's right after the last item, okay? And then let's see how do we consider as circular array concept, okay? So suppose we change it to as integer. So we first add 100, okay? So 100, I'm going to add it here. And the front index is at sub-0, okay? Initially, suppose it's empty. Initially, when it's empty, so m front is at sub-0 and m back is also at 0 at this time. After I add 100, and front won't change, it's still here. But the back going to be changed to sub-1, okay? And then I add 200. So 200, I added, and the back index going to be changed to the next empty one after the last one you added. Then I add 300. Okay, so I add 300, and the back index also change it to the next empty one, okay? And then I add 400. So 400 is added, and the back index is here. Okay, and then I add one more 500. So I add 500. So the back index then going to be changed to 5, is it? So now front is 0, back is at what? At 5, is it? So now my question is, can I add 600? Is it? You just think about it. Can I add 600? Just think about, based on this circular diagram, can I add it? If I add it, assuming I added 600, then where is this m back index going to be? So it's going to be updated to here, is it? Based on this diagram. So it's 0, is it? 0. Okay, and the 0, this is a full condition, is it? But at the very beginning, when we discuss, when we said the stack is empty, front is 0. Then at that time, back is 0, is it? And then just compare, like, then how do you differentiate these two scenarios? This is empty scenario. And this is a full scenario, is it? So how can you differentiate these two cases? So there is no way to differentiate, is it? That's why we said you always let the back index point to the one that after the last one, but it's an empty one. So you cannot do this. Okay, you cannot do this. So the m back, in this case, it should be 5, is it? But then the question is, so now if I want to add, I do want to add 600, what should I do? Is it? So the only way you can do is you remove 100. You remove it. Is it? You remove it, the front index change it to where? Front index change it to 1. Is it? Change it to 1. And now you can add 600. Now I can add 600. Is it? But the back index change it to what? Back index change it to 0, is it? And previously when we discussed like a stack, for the stack, the top index, each time you add a new item, the top index, you do top plus plus, is it? Okay, so here the concept based on what we just discussed, whenever we want to add a new item, the m back, it's also plus plus, is it? Increment by 1 until it reaches 5, is it? When it reaches 5, it's okay. But now m back is 5, is it? And if you still do plus plus, it's going to be 6. But within your array's index, array index is from 0 to what? To 5. You don't have 6, is it? You don't have this 6. So how do we solve this dilemma? Is it in this case? Because it's going to be out of bound exception, error, is it, for the array. So that's the concept of circular. And based on what I just draw, then you see it's, oh, this is simple, is it? Because it's just a jump to the next available one. But the index not increment by 1 to 6. It's decrease from 5 to 0, is it? So how do we achieve that, is it? So to achieve the concept of circular array, there is a very interesting operator. Basically, you all learned this module operation. Okay, if we apply this, then we can solve the dilemma, is it? So let's see, the array size in this case is 6, is it? Then let's see, 0 module 6, you get what? You get 0, is it? 1 module 6, you get what? You get 1. And 2 module 6, you get 2. And 3, you get 3, is it? 4, you get 4. And 5, you get 5. But let's see, 6 module 6, you get what? You get 0, is it? And 7 module 6, you get what? You get 1. 8 module 6, you get what? You get 2, is it? So no matter what number is, if you module 6, you can only get from 0 to 5, is it? So that's perfectly match the array's index. The array's index, is it? So this concept, we call it a circular array. Okay, so the array itself is still the regular array that we already learned, linear array, is it? It's just whenever you deal with its index, then you apply the module operation. Okay, you apply the module operation, then with this module operation, you can guarantee that your array's index will always be in bound. So it won't cause the out of array index out of bound issue, okay? So this concept, we call it a circular array. And with the implementation of Q class, and this is a popular, very popular way to implement using circular array, okay? So it's, when we implement like this, we let the front index always point to where the front item is. But the back index, remember, it doesn't point to the last item, point to the one that's beyond the last item, even in this circular array scenario, okay? So that you always have a gap, okay? You can maintain that gap. And why do we need to maintain that gap? Previous I explained the concept. Because with the circular array scenario, then you can differentiate the Q is empty versus Q is full cases. So you can differentiate both cases. So then let's see what is Q's full, Q's empty condition. We know it's, so empty condition is front equal to back. That's the empty condition, is it? So empty. And the full condition, based on what we just discussed, is what? It's the back index, is it? If it's +1, is it? So the back is at 500 here. So here is the back, is it? Here is back. And it's already empty, so assuming 100 not removed, okay? And so back +1, is it? But then you module 6 in this case, is it? And if it's equal to front, is it? Then in this case, you say, oh, the Q is already full, okay? You cannot add any more item, okay? So the adding new item. So basically, the operation for the enqueue, is what? Your back index, is it +1? But you cannot just let it +1. It should do what? Should also module the capacity of your array, okay? So that's for the enqueue. One of the major things you needed to do in enqueue, is it? Whenever you do dequeue, let's see. So now we already move 100. We may remove 200, is it? So the M front is going to be updated to here, is it? So you can see whenever you remove the front index, it's not decrease, is it not decrement? It's increment also, is it? So basically it's what? Is front updated to what? To front +1. But you cannot always +1 because you need to solve the problem as jump from sub5 to sub0, is it? So how do we solve that dilemma? It's the same thing. You do module 6. Then in this case, you can guarantee your both front index and the back index. It's always going to be within the array's index legal range. Okay, so that's the general idea about a circular array. So I'm not sure because it's kind of messy drawing there. So are there any questions so far about this circular array concept and the updating of the front index and the back index? Are there any questions? Is it clear? Let me see. Oh, it's clear. Is it okay? If it's clear, that's good. Then I'm going to move forward. Okay. Okay, so we now have the concept of the circular array. So now let's go into our coding part. Okay, for the Q class that we are going to create. So here, we first start with an integer Q, okay, integer Q. So over here, we define our Q class. Is it like I just explained? We have front index and back index, and we are going to use an array, okay? And the default capacity for this Q is 6, okay, just like what I draw, okay? And so this is a default constructor for the Q. So the default constructor, what it does is create an empty Q. Empty Q. So what it does is, you can see I initialize both front and back index, is it? So sub0, sub1, sub2, okay, kind of like the sub5, is it? And at this point, the front and the back, is it? Both point to here. That's an empty one. And at the same time, you have your array created on heap, is it? Okay, so that's this part. And then, okay, then we have a second constructor, the explicit one, is it? And this time you're going to create your queue with a specified capacity, is it? But you still create an empty one, but it's just array capacity. You change it. Okay, then let's move to C, in-queue operation. Okay, for in-queue operation. In-queue operation, and let's see here. The in-queue operation, and this is sub0, and sub 1, sub 2, sub 3, sub 4, and sub 5. Is it? And initially your front and your back both at sub 0 at here. Is it? Okay, now I want to add 100. Is it? I add 100. So based on this definition is what? You update your back index. Is it? So how do you, so the item, you're going to assign 100. So item is 100. Is it? My back at this point is 0. Is it? So 100. So M array sub 0 is 100. So you add 100 here. Is it? But then you need to update the back item. Is it? So you need to update back here. Is it? So it is 0 plus 1. Then module 6. That's why you have 1. Is it? So back updated to 1. Okay. And what does this do? Is it? This is like previously I explained, try to, later on we can see, okay. This is try to see if your queue is already full or not, okay. And then let's see, I cannot move. Just need to stop annotation. Okay, so the double quote we can later on come back. And then next, let's see the DQ. For this is a DQ. DQ is to remove the front item. Remove the, so we have sub 0, sub 1, is it, and sub 2, and sub 3, sub 4, and sub 5, is it? And suppose we add 100 here, so front is here. And suppose we keep adding 200, then back is here. Is it? And if I add 300, then back is going to be here. Is it? If I add 400, then back is going to be here. Is it? If I add 500, then back equals back plus 1, then module 6. Is it? So it's what? It's 4 plus 1, then module 6. That's why you get it 5. Is it? So it's going to point to 5. Is it? So that's the current scenario of your queue. Okay. Then here I said I want to remove the front item. Is it? You remove basically this same concept as stack. You cannot really remove it from the array. Is it? What you can do is you just update front index. That's what you can really do. You cannot move that item from the array. Is it? So basically you want to remove 100. Is it? So then what you do? You update the front index. Is it? So m front 0 plus 1. And then module 6. Is it? So I get 1. Is it? So that's why the front index updated to 1. So that's how DQ works. Is it? But of course, you need to check before you can remove. You need to check if your queue is empty, and this is the empty condition. Is it when both front and the back are the same value? And also be careful. It doesn't mean that front and the back both need to be at sub-0. They can be anywhere. But if both of them point to the same slot, then that means your queue is empty. Okay, so this be careful. It's just those two index just need to be the same. That's it for the empty condition. And then next, let's see how we get to the front item. That's pretty straightforward, is it? So right now, 200 is the front item. Where it is? Oh, it's at index 1, is it? So you just return the corresponding arrays item, is it? But of course, you need to make sure it's not empty, okay? Okay, so that's about InQ, DQ, and the front item. And to check if it's empty, that's pretty straightforward. You just check if the front index and the back index are the same. Okay, so nothing new here. And let's come back to take a look here. So this is to check if the queue is full. Is it? The queue is full condition is it meet this condition. So we have 100, 200, 300 to 400 and 500. That's the condition. Is it? And suppose we remove 100. Is it? Then front is going to be here. Is it? So I can add 600. Is it 600? Then the back is 0, as if front is 1. So in circular array scenario, you can also see the back index can less than front index. Is it? If you implement it with a linear way, like this, then this is not true. Then that's not true. Not true, is it? But with circular array, then it is true. So it can be guaranteed, is it? And why we say we want to use a circular array versus a linear array, you may ask, is it? Because just think about the scenarios 1, 2, 5, 6, is it? So here we have 1, 2, 3, 4, 5. Is it? Then you have this empty. Is it? And just think about right now you cannot add, but if I remove 100, then I can add a new item. Is it? I can add 600. Is it at the back? Is it? Okay, but the array index is out. So the only way you can solve the problem is you need to shift all of the array items. Is it shifted by 1 slot? So each time, just think about when your array, is it, you already started to remove item. Then, so whenever you do DQ, then it involves shifting the array. And if for small size of queue, it doesn't matter a lot. That shifting won't cost too much efforts. But think if your array, if your queue is very large, that involves maybe millions of items, then each time you do DQ, you need to shift millions of times. So that's just a waste of efforts, is it? But you see, with circular array, then no shifting. You need to worry. Is it no shifting? What you need to do, you just need to use this circular array concept. You just need to use this module operation, and it will completely take care of whatever scenario it is, all of the scenario, is it? Okay, so here I explained why we need a circular array. And then so now my key point is to explain the full condition, is it? So now the queue is full, the back is here and the front is here, is it? Between back and the front item, we have an empty slot, is it? And you can keep removing, like remove 200. Then front is at 2, is it? And now you can add 700, is it? So back is 1. Is it? Back is 1. Okay, so what's the full condition? The full condition is going to be back index plus 1, is it? In this case, module 6, is it? So what it is? It is 2, is it? 1 plus 1 module 6, you get 2. Okay, front index is what? Is 2. And if you compare this two the same, is it? So that's the full condition, okay? So whenever we implement with circular array, the Q's full condition, you need to write like this. So the back index plus 1 module array's capacity, that and equals to the front index. Okay, that's going to be your Q's full condition. Okay, we understand the InQ, DQ, front, empty condition. What next we want to explain is about how do you output of your Q's items, is it? Okay, so over here, let's see. You want to output your Q item from the first item all the way to back item. Is it all the way to back item? And generally speaking, for our for loop, normally what you do is I start from 0, I less than size, and then I plus plus, is it? But here we needed to be careful is versus regular I plus plus. You cannot just do I plus plus, is it? Because we consider the circular array, is it? So from 5, jump back to 0. If you do I plus plus, it's going to be 6. You cannot get back to 0, is it? So how to solve that issue, the dilemma, and won't impact all of the other cases is, okay, you do I equals I plus 1, then modules, whatever the array's capacity, is it? Then this won't cause any issue, and it take care of the circular array. So here, that's the circular array. Place into the row, is it? And all the other thing, it's similar as what we already learned, is it? So we use a stream builder and to get off the items to the stream builder, and then we convert it to a string, okay? So nothing else new. It's just over here it shows whenever you try to loop through the Q, implemented with a circular array, you just need to be careful, okay? Whenever you do increment, don't forget the module operation, okay? That's what here the major concept is. And then next, let's take a look. In this implementation, I also use a exception to check if the queue is empty. If the queue is empty, I'm going to throw exception, is that? And this exception is not the checked exception, is it? It shouldn't belong to the checked exception. It belongs to unchecked exception. So that's why I extend the exception. So I create an exception. I call it empty queue exception. And I let it extend from the runtime exception. So it's unchecked, okay? And what it does, it's pretty simple, this one. Is it just, okay, output the queue is empty information. Okay, then in our code, you can see here, is it for my DQ operation, is it? And if it is empty, then I'm going to throw that empty queue exception, is it? So when it is empty, I throw that exception. For the front operations similar, I throw that empty exception, okay? So this is regarding the exception. And also in this version of the implementation, our queue size is not fixed, okay? We can let it change. So whenever each time your queue is full, I'm not just output like, oh, queue is not is full, you cannot add more. What I'm going to do is I'm going to double the size, is it? So how do I double the size is I need to create a new array with twice the size of your initial arranged array's size, is it? And also you want to do the count, how many items in this array, etc. So what over here it does to find the number of items. And here there's another quite useful concept is with circular array, if you wanted to count the number of items in your circular array, here you can do that. Because generally speaking, with a linear array, if it's linear, as it is always the back minus the front, you want to find the offset. Is it that will give you the size? But with circular, you cannot do this. Is it because your front may be here and here is your back? Is it? And this case is 0, 1, 2, 3. Is it? Your front is greater than your back. Is it? And if you do 1 minus 3, you will get a negative value. Is it? That cannot give you the number of items within the queue. Is it? So in circuit, to solve this dilemma is you just add whatever the item, the capacity of the array. In our case is 6. Is it? Then you module 6. What do we get? We get 4. Is it? And if you take a, say, in this case, you are going to have 1, 2, 3, 4. Is it? So you're going to have 4 items. So that tells you. So to find the number of items in a circular array, just remember to write a single statement that will take care of the cases is you do front minus back. And then you do just plus whatever the capacity and then module the capacity. So then in this case, you use this single statement, but you take care of all of the cases so that you don't need to worry, okay, write the if else, if front less than back, what do you do? If front greater than back, what you're going to do? You don't need to worry of this. You just use this single statement that will take care of everything. Is that? And over here, we want to double the size. So you want to have a much bigger one. So maybe this first half will take care of that circle, and the other half is your new array's size. You increment its capacity. So how do we do it is then what you're going to do, you're going to copy item by item, to this larger one. So you're going to copy one by one, the item to this larger size. And then you're going to reset the front and the back item. You're going to reset it. And then with the new capacity, you can add more item. So that's what this function does to double the capacity. So that's why for our in queue, okay. So if your queue is full, what we are going to do is we're just going to use a double size array. We're going to use that new array, and then you can just continue what you already did. Okay. So this is to deal with the full condition, and we can double size our queue. And what is the last operation here is about clone. Maybe I can leave it to tomorrow's class. So let's take a quick look at the application part about queue. Okay. So here, with our queue class already created, then you can create a new queue instance called Q1. Then you can check if it's empty. So we already know this, And if you want to add item, you see, you can just keep calling in queue, And you can call its toString and call its front operation, And to do all of the operations to do whatever task you want to complete the task, is it? And what is the next one shows, let's see. Over here, yeah. Over here is I write a function called search. I want to find some item within the queue, is it? And over here, I don't want to change my original queue, is it? So that's why I call the queue's clone function, create a deep copy of the queue. Okay, and then I'm going to search of the item on this clone. So this is also often used with the application of queue. You use the while loop and you use the queue empty condition to check, and normally you use the front item you want to do something. In this case, you're going to check if the front item is the item you're looking for, is it? If it's not, then you're going to keep doing dequeue. So this kind of while loop with queue empty, and within it you can do the front and dequeue used quite often with the queue operation, is it? And finally, you can check if you find the queue or not, or find the item in the queue or not. Okay, so that's the major information regarding today's class. So we learned the concept of queue, is it? So we know it's double, you can access at both ends, is it? You add at the back and you remove at the front. We call it in-queue and dequeue operations. And then the next part today we learned is a new concept called circular array. Okay, so that's just a conceptual. Okay, the array itself in Java code will implement still regular array. It's still linear. Okay, array itself is a linear data structure. Okay, and here we just use that module operation to simulate when you want to treat this array in a circular way, so that you can avoid a lot of dilemma, okay? Because if you implement this queue with a linear queue, then we have the dilemma as we need a lot of shifting operation. But with the way to implement a circular, then not such a worry that we basically get rid of those worries. This is a shifting cost. So that's the general information about today. Do you have any other questions? Is everything good? Any other questions? Yeah, please, everything is good. No questions. So if there is no question, then I'm going to see you all tomorrow. Okay. So bye.
Bye.